Imagine an object larger than a mountain range racing through our solar system at more than 210,000 kilometers per hour, and it has a secret that even the most advanced telescopes on Earth are struggling to decode. This isn't science fiction, it's the fascinating story of 3I Atlas, an interstellar traveler that's giving astronomers an unprecedented opportunity to study something from beyond our solar system. For decades, astronomers have looked to the stars, imagining what life might be like in distant systems. But until recently, our understanding of what exists beyond our solar neighborhood was based on indirect observations and theoretical models. That all changed when 3I Atlas passed through our cosmic backyard. Unlike previous interstellar visitors like Oumuamua, which passed by quickly and became too faint to observe, 3I Atlas has been large and bright enough to stay in sight for a significant period, offering scientists a rare opportunity to study it in detail. Telescopes around the world have turned their attention to this mysterious object, closely monitoring every aspect of its behavior. They've tracked its brightness, rotation, gas emissions, and trajectory as it travels through our solar system. Each measurement they collect helps refine existing models about how interstellar bodies behave when they encounter a new star system, and what scientists hope to learn is beyond what we could have ever predicted. Could 3I Atlas be a comet unlike any other, or is it something entirely new? Could it hold evidence of planetary materials from a star system so far removed from ours that its formation conditions are a mystery? These questions remain as astronomers dive deeper into the data. The answers to these questions could unlock a whole new chapter in understanding the building blocks of the universe. What scientists are hoping to reveal is more than just a distant system's history. It's possible that 3I Atlas may provide the first ever direct evidence of how planetary materials evolve across the galaxy. Each passing day, as scientists gather more data, they are getting closer to revealing secrets that have remained hidden for millennia, but the clock is ticking. As 3I Atlas speeds away from our sun, it will eventually disappear into the depths of interstellar space, and with it, the chance to gather this invaluable data may be lost forever. But how long do we have, and what might we still learn before that moment arrives? This is where the investigation takes a turn. Interstellar objects don't stick around for long. Their extreme speed means they can travel across our solar system in a fraction of the time it takes most of us to blink. That's why astronomers are racing against time to collect as much data as possible from 3I Atlas before it fades from view. So far, astronomers have been measuring everything from its brightness to the gases escaping from its surface, but there's still a lot of mystery left to unravel. Comets in our solar system usually consist of a mixture of ice, rock, and dust materials that form during the early stages of planetary formation. These materials can remain relatively unchanged for billions of years, preserved in the cold outer reaches of the solar system. However, 3I Atlas might not follow the same pattern. If it truly formed around a star other than our own, its internal structure could be drastically different. The chemical environment of another star system, its temperature, radiation, and the nature of its original protoplanetary disk could have produced icy bodies with completely unfamiliar compounds. This opens up the possibility that 3I Atlas may hold information that's unlike anything we've seen before. Already, early observations suggest the presence of methanol, one of the simplest organic molecules, which may provide clues to the chemical conditions in the system where 3I Atlas was born. While methanol itself doesn't prove the existence of life, it is an important building block in complex chemical reactions that occur across interstellar space. By analyzing the amount of methanol and other molecules surrounding the object, astronomers are hoping to gain insights into the environment where it originated, an environment that we can't observe directly with our telescopes. This data may represent the only direct sample we'll ever get from a distant star system. And as 3I Atlas continues its journey, scientists are uncovering more clues that could reshape our understanding of planetary systems beyond our own. Yet, one question remains at the forefront of the investigation. How exactly did 3I Atlas come to be here? What can it tell us about the vast and mysterious journey it's been on for millions, if not billions, of years? Let's keep exploring. Stay tuned for more. As the days go by, the mystery of 3I Atlas deepens. Astronomers are carefully monitoring how the object behaves as it nears the Sunday. The early signs of gas escaping from its surface were intriguing, but now researchers have begun to notice more complex patterns. This interstellar traveler is not behaving like any typical comet. Instead of steadily increasing in brightness as it approaches the Sun, 3I Atlas shows sudden bursts of activity that defy our expectations. This irregular behavior suggests something far more complex is happening beneath the surface. As scientists continue to track these sudden changes, they're considering several possible explanations. One idea is that the object's surface could be covered in volatile materials that when heated by the sun, fracture and release gas in unpredictable bursts. As the object warms up, cracks could form, trapping gas inside, and when those cracks break open, we see sudden, dramatic spikes in brightness. This could be one of the reasons why 3I Atlas appears so different from comets we are familiar with. But that's not the only possibility. Some scientists have also considered that 3I Atlas might contain pockets of volatile compounds hidden beneath its surface. If that's the case, the heat from the sun could slowly penetrate these layers, causing gas to build up and eventually escape explosively. However, there's a twist. The gas emissions from 3I Atlas seem to be happening much farther from the sun than most comets become active. This raises a fascinating possibility. The compounds trapped inside 3I Atlas could be more easily vaporized than the materials we typically see in our solar system. Methanol and other organic compounds tend to sublimate at much lower temperatures than water ice, meaning they could begin to evaporate long before 3I Atlas even gets close to the Sunday. This unique behavior may be an important clue about the chemical makeup of the object and the conditions in the system where it was formed. The more scientists study 3I Atlas, the more questions arise about its composition, its activity, and its journey across the galaxy. While all these findings are compelling, they also raise another crucial question. What does the irregular acceleration of 3I Atlas mean for our understanding of interstellar objects? As scientists continue to track this object, they've noticed a slight deviation in its expected trajectory. Normally, objects like comets follow predictable paths determined by gravity, but 3I Atlas is doing something different. It's experiencing what is known as non-gravitational acceleration. This is a term used when an object's movement cannot be fully explained by gravity alone. In the case of 3I Atlas, this additional acceleration seems to be caused by the release of gas from its surface. As gas escapes, it creates a small force that can alter the object's motion. But what makes 3I Atlas so unique is that its acceleration doesn't follow the usual patterns observed in comets. This irregular acceleration has caught the attention of scientists, sparking debates about the true nature of this mysterious object. Could there be something hidden beneath its surface that's causing this unusual behavior? Is there a chemical reaction at play that we've never seen before? These are the questions that astronomers are racing to answer before 3I Atlas fades from view. Each new observation adds another layer to this cosmic puzzle, but the answers are still elusive. And as we look to the future, we can't help but wonder, what else could we learn from 3I Atlas before it disappears forever. The mystery deepens as astronomers race to uncover more details about 3I Atlas before it vanishes into the vastness of space. The object's unusual acceleration isn't the only oddity that's keeping scientists on edge. One of the biggest challenges they face is figuring out where this object actually came from. Its trajectory suggests that it came from the outer reaches of the Milky Way, but tracing its exact origin is a daunting task. Astronomers know that interstellar space is incredibly vast and that most objects traveling between stars wander for millions, even billions, of years before they encounter another planetary system. But 3I Atlas is different. By measuring its speed, direction, and trajectory, scientists are trying to piece together where it might have come from. But so far, the answers have been frustratingly unclear. What they do know is that the object is not gravitationally bound to our sun, which means it didn't originate in our solar system. It's a visitor from far beyond our cosmic neighborhood. But how did it end up here? What kind of cosmic event could have launched such a large object into interstellar space and sent it on a journey that would take it through our solar system? One possibility is that 3I Atlas was ejected from a young planetary system where massive planets like Jupiter were still forming. When these giant planets shift positions, they can scatter smaller bodies out into interstellar space. In some cases, these objects are accelerated to extreme speeds, allowing them to escape the system completely. This process isn't rare. Many astronomers believe that planetary systems across the galaxy eject countless icy bodies during their early formation stages. And if that's true, then the space between stars may contain trillions of wandering objects like 3I Atlas, quietly drifting for millions of years. But here's the catch. Most of these objects are too small to detect. 3I Atlas is an exception. Its large size makes it an incredibly rare example of this population, which means it's giving scientists an unprecedented opportunity to study an object that has traveled across the galaxy for millions of years. The fact that 3I Atlas is so large also raises another important question. If this object was ejected from its original system, the event that launched it must have been incredibly powerful. Gravitational interactions with massive planets, or the chaotic early stages of planetary formation, could have caused this object to be expelled from its home system. If that's the case, it would mean that 3I Atlas has traveled across the galaxy for millions or possibly billions of years before finally passing through our solar system. That's an incredible thought. An object formed around another star, carrying with it chemical clues about a distant planetary system that no telescope has ever observed directly. It's a physical sample from another star system, a rare and valuable piece of cosmic history. But while scientists were still studying its possible origin, new observations added another unexpected detail. When astronomers continued monitoring 3I Atlas, they made a surprising discovery. Its movement didn't quite match the predictions of gravitational models. This subtle deviation in its motion became one of the most talked about aspects of the investigation. While scientists expected the object to follow a predictable path based on gravity alone, 3I Atlas was showing signs of an extra force at work. This non-gravitational acceleration was something scientists had seen before in comets, but not quite like this. Normally, when a comet gets close to the sun, the heat causes the ice inside it to vaporize, creating a jet of gas that pushes the object along. This gas release can change the comet's trajectory slightly, but in the case of 3I Atlas, the acceleration didn't behave like a typical comet's. The gas release seemed to happen in irregular bursts, not in a steady stream, suggesting something unusual was going on. astronomers started to consider other explanations for this strange behavior. Could 3I Atlas have pockets of volatile material hidden beneath its surface? If so, the sun's heat could be gradually warming these materials until they vaporized, creating bursts of gas that pushed the object along. But this still didn't explain everything. Some of the bursts were happening when the object was still far from the sun, much farther than most comets become active. This suggested that the gas release might be occurring at much lower temperatures than usual. This was a huge clue. Methanol and other organic compounds can sublimate more easily than water ice, meaning they can turn into gas even when the object is still far from the sunday. If 3I Atlas is rich in methanol, this could explain why it's becoming active so far from the sunday, and this would also suggest that the object may have a chemical composition that's completely different from the comets we see in our solar system. This new discovery adds another layer of complexity to the mystery of 3I Atlas. The more scientists study it, the more questions they uncover. It's clear that this interstellar object is unlike anything we've ever seen before. But the deeper scientists dig, the more they realize how much there is to learn and how little time they have to gather all the data before 3I Atlas disappears into the vast darkness of interstellar space. As the days go by, astronomers continue to collect valuable data from 3I Atlas. Every observation adds another piece to the puzzle, but there's still so much we don't know. One of the biggest questions remains: what exactly will happen next? With the object's extreme speed, it's only a matter of time before it fades from view and continues its journey into interstellar space. Right now, telescopes around the world are watching it closely. Every small change in its brightness, every burst of gas, and every shift in its trajectory is being tracked and analyzed. This is a once-in-a-lifetime opportunity to study an interstellar object up close, and scientists are working around the clock to gather as much information as possible before it disappears. But there's a deeper significance to this investigation. 3I Atlas may not just be a curiosity, it could hold the key to understanding the formation and evolution of planetary systems across the galaxy. By studying this object, astronomers are piecing together clues about how planetary systems form, how they evolve, and how they sometimes eject pieces of themselves into the vast emptiness between stars. The more scientists learn about 3I Atlas, the more they realize that it could offer insights into the processes that shaped not only our own solar system, but countless others as well. This object could be a snapshot of a planetary system that formed under completely different conditions from our own, a glimpse into a part of the galaxy that no telescope has ever seen before. So, while the mystery of 3I Atlas continues to unfold, one thing is clear: this is an extraordinary opportunity for science, and the discoveries that come from it may shape our understanding of the universe for years to come. As we reach the final chapter of this incredible investigation, the questions about 3I Atlas are still far from answered, but the journey so far has been nothing short of remarkable. Scientists have uncovered new insights into the behavior of interstellar objects, and they've gained valuable data that will shape future research for years to come. Right now, 3I Atlas is still visible to astronomers, but its time in our solar system is running out. Soon, it will disappear into the vastness of space, and with it, the opportunity to study it up close will be gone forever. But even as it fades from view, the lessons we've learned from this object will continue to resonate. 3. Atlas has shown us how much we still have to learn about the cosmos, and how much more there is to discover beyond our own solar system. For now, all we can do is watch and wait. But one thing is certain, the story of 3I Atlas has only just begun, and the mysteries it holds may continue to unfold long after it has vanished from our skies. If this journey through the unknown has sparked your curiosity, don't forget to like, share, and subscribe to stay up to date on the latest discoveries from the universe. And remember, there's always more to explore, more to learn, and more to uncover. Stay curious and keep looking up.